Cool, let's get going. So what I want to start with today is a little bit of a follow on from the previous lesson, and that is using the sine rule. So I want to solve for this unknown angle over here. Who would like to tell me how I start going about finding this unknown angle x in the following triangle? Who feels like they'd be willing to share some of their knowledge? Hi, Nawiza. Welcome aboard. Okay, Zandesile, what do you think we should do to start with? Can you hear me?
Yes, I can. I think you're gonna say sine x divided by 19 is equals to sine 28 degrees
perfect,
divided by 14.
Absolutely perfect. Thank you so much. Now, if you're trying to find the value of x, the problem I have is that this x is still a bit hidden away. What are my next steps? What do you think I have to do next, Sandisile?
Oh, so you have to cross multiply.
Okay. And so I take it the 19 is what you're going to bring across?
Yes, it's gonna be 14 sine x.
Okay, so you get, oh, well, okay, you could do that, but I want to get the x by itself, hey? So all I want to do is move this 19 to the other side. And so basically what I'm doing is I'm multiplying both sides by 19. So what would I get on this side? Or would you agree with me? Would you agree with me that, does that make sense to you? Like what I did there?
Yes, it
okay.
does. Yeah.
Thank you so much, Sadisile. Now, I want everyone to try and find me the value of x now. So, and if you're unsure or you're new, maybe you know how the sine rule works, maybe somebody can help us in the chat. But basically, I want to find the value of this x. And I should have my calculator showing. So Fatejo had said the inverse. So how do you find the inverse? You go shift, sine, and you get this little sine minus 1 thing. And then inside of that, you need to put the values that are here. So what do we get for that? So 19. So what are we going to get for the value of x? It looks like the maths is saying that x is equal to 39.58 or 58 degrees. Now here's something interesting, and I didn't do this with you in the last lesson. When you're finding angles using the sine rule, what the sine rule says, and I would encourage those who are new to go back and have a look at the previous lesson. I'll just show you what it looks like, where we basically spent the whole lesson practicing how to use the sine rule. Okay, so if you go back and see the recordings, you'll see that lesson. But when we're starting to find angles, we go the sine of an angle divided by the side opposite equals the sine of another angle divided by the side opposite. And then we try and find this angle. But something's worrying me. When I look at 39.58 and I see that value and I look at the size of this angle, something is a little bit off. What do you think is a bit off about this question? What doesn't strike you as being completely on the money? When you look at the value of that x and then you look at the picture. Yes, Nompemelo. It is an obtuse angle, and yet from the trig equation that you generated, you have got an acute angle. And so something's a bit fishy. Something must have gone wrong here. Well, actually, nothing went wrong. This is called the ambiguous case. And when you use the sine rule and you're solving for an angle, in some situations, there's two possible answers. And the reason there are two possible answers is because the sine of x is also equal to the sine of 180 minus x. Now that might sound a bit random, but another way of thinking about this is to say, well, the sine of 150 or the sine of 30, is equal to the sine of 150 or 180 minus 30. So whenever you have an angle that you solve with sine in the trig equation, it is possible to get another answer by going 180 minus whatever that angle was that you found, and that will still give you the same answer. And I didn't show you this in the previous lesson because I thought it might be a little bit too much, but basically all you need to worry about is if you get an acute angle from this equation and the angle clearly looks obtuse, all you need to do is go 180 minus the angle that you found. There's only two possible options. And the reason this happens is because of this idea that the sine of an angle in quadrant 1 is the same as the sine of an angle in quadrant 2. So given this information, find me the value of x that will fit this angle over here. Find me the value of x that, so we know 39.58 is related to my answer, but it's not my answer. What is the answer that's going to fit this triangle going to be? So the answer is going to be 140. So 140.42. And that makes sense to me because it's an obtuse angle. It's an obtuse angle. For those who have done trig equations, you know how when you have the sine, a sine general solution, you always have an answer in quadrant 1, and you also have an answer in quadrant 2 if it's a positive angle. This is what's happening in this situation. And when students get a bit worried about the fact that there's two answers and they say, how do I know what the correct answer is? I say to them, look at it visually. If you've got an answer which is acute, to find the obtuse answer, all you do is go 180 minus the acute angle. Okay, and you just look at it visually to determine if it fits the situation. Give me a thumbs up if you follow my logic there. Give me a thumbs down if you're feeling a bit like a boxer who's been whacked. Okay, it's nothing to worry about really. It's just the fact that there can be two answers when you're solving for an angle. And if you want to do really well at maths, you have to be aware that the sine rule has that little uncertainty. Okay, and for those who are new to the sine rule, don't be afraid to go back and watch that previous lesson. Now, the main focus for today is on something called the area rule. And so I do want to take some time now to move towards that for today. So just to get us in the mood for area, what I want you to do is I want you to try and solve this multiple choice question for me. Here's a triangle. What is the correct answer which gives me the area of this triangle? For those who are unsure, also remember that this lesson is recorded and you can rewatch it after the time. And so you get a chance to watch it again at a later stage. Maybe somebody can help us. If we want to find the area of a triangle normally, what do we normally have to do to find the area of a triangle? Letty, I see your hand is up. Let's unmute you, Letty.
Hi, sir.
Hey, Letty.
So to find the area of a triangle, we have to say half base times breadth, and looking at the squares of the triangle, there's 2 and then there's 3 on the side. So it's half of 2 times 3, which will give us 3, and the answer is A.
Perfect. Wow, you know your stuff. Thank you very much, Letty. So Letty is quite correct. The area of a triangle is a half base times height. The important bit is you need the base and the height to meet at the right angle. And so to get the answer here, you go a half times 2 times 3, which should just give us 3 units squared. And then you are good to go. So the answer would be A. The height is not 2/3. The height is just going to be, well, if this is the base, then this would be the height, or you could do it the other way around, but the height and the base always meet at the right angle. Okay. Now, let's do another question involving area, but a slightly, I won't say harder, but let's do this one. Calculate the area of this triangle. Using what Letty gave us a bit of help there by saying we can find the area of a triangle by going a half base times height. You might need to read into your triangle toolkit to help you out there. Yeah, I just want to check that you are cool and that are you with us? Just want to make sure.
Yes, I am.
Check in and
I just forgot to switch on my
perfect.
camera.
Okay,
Sorry.
fantastic. No worries, no worries. Cool. What is the main problem with finding the area of this triangle? I feel a bit stuck. Maybe somebody can help me. What is different? What is different to before? What tool might I need to use? I feel like the base and the height have to meet at the right angle. And the problem I have is that I don't know what the height is. Does anybody have a suggestion how I can find the height?
I see Letty has their hand up, however, they're just not unmuting.
Yes.
There we go.
Oh.
So first we're gonna
Hey,
use the
hi, Letty.
Hi, sir. The
Hey.
Pythagoras of, and then we're gonna say 25 squared is equal to 7 squared, and then we're gonna find the missing one. Whatever we get, we're gonna subtract it from 625, and then we're gonna find the answer, which is 24. So the height is 24. Then we're gonna say half of 24 times 7. And that will give
Letty,
us.
you definitely know your stuff. Can I ask you, Letty, what did you get for the length of this yellow bit? What did you get for your X there?
24.
24. Perfect.
Yes.
That's absolutely perfect. Thank you, Letty. That is perfect. So now what we're going to do then is to find the area of this triangle. We're just going to go a half times 7 times 24. And when I do that, a half times 7 times 24, I'm going to get 84, which gives me the answer of this one here, which is A. Cool. Now, the reason that this is important is that basically, if you didn't have the 24, you couldn't really find the area of the triangle. But now this is still kind of grade 9, grade 10 work. So let's take it up a notch for this new tool called the area. So let me make this bigger. And let's see if I can get rid of this bit here. Zoom in a bit. There we go. Okay, now, if I say to you, what is the area of this triangle? What is my first problem? What is my first problem? You guys are smashing the last 2 questions, but this one, something looks a bit different. What do we need to recognize and what's the problem? KG, I'm going to unmute you. KG, what do you the problem here?
Good evening, sir. This triangle is not right-angled.
Yeah, the problem is this and this are both, you don't have a right angle triangle. Now, what you can do in these situations is you can use something called the area rule. And for now, I'm not showing you the proof. I'm just showing you how it works. You go a half times the length of one side times the length of another side times the sine of the angle in between those two sides. So essentially, you have one side over here. So we can even call it, maybe I should do this with you. So I'll make this 6, and this is going to be 5, and then this is going to be the sine of 78. And this is called the area rule. And as long as you have two sides in the included angle, it finds the area of any triangle. So I want you to put that in your calculators and tell me what you get for the area of this triangle. So 0.5 times 6 times 5 sine of 78. And we get 14.67, and this would be units squared. Okay, so, and the reason, the proof of this area rule depends on the fact that basically you use trigonometry to find the height of this triangle, and then you use that height that you find using trigonometry to power the rule. But I'm not going to go into the proof today. All I'm going to do is make sure you understand the process. So give me a thumbs up if you feel like you understand how to apply the area rule. Give me a thumbs down if you feel like you don't know how to apply the area rule based on the example. Okay, cool. Then I think what we need to do is use this new powerful tool that you found. So find me the area of this triangle. Find me the area of this triangle. What do you think? So think about what the structure of the area rule says. There's always a half, and then there's two sides, and then there's a sine, and then there's an angle. So what do we have? We have that and that. Let me get that. What do we get for our final answer there? It's actually such a nice rule. It's so convenient. It's you kind of wish they taught it to you earlier in school when you see it. Although you would have to know about trigonometry. So I've got like a messy, well, I've got a surd form there, but if I hit the SD button, I've got the area is 18.19 centimeters squared. So as long as you've got two sides and angle in between, you don't really need to worry about the height anymore because the area rule takes care of that for you. Okay, cool. Then let's move on to another one, just to make sure that you've got this. And then if you show me you can do this by yourself, I will make it a bit tougher for you, but let's make sure we know how to find the area of this triangle. Chop, chop, no problems. Like it feels like tying our shoelaces. That's how easy we want it to feel. So Tebogo, if you're dealing with the quantity of area, you do want to write whatever units you've got squared, because area is literally a square unit. It's like when you say like the area of this is 16, it literally means you're fitting 16 little squares inside this shape. So the units are important, but you can only ever lose one mark normally. But you know, you want to get it right if you can. So it's 8, 10. What are we getting for our answer for the area of this one? Yeah, we should be getting 39.27 centimeters squared. So just to give you some interpretation of what that means, when we say 39.27 centimeters squared, we literally mean you can almost fit 40 squares that are 1 centimeter by 1 centimeter big inside of this. So if you've ever wondered what area actually means, when you say the area of the triangle is that, it means, and the reason you say centimeter squared is you're literally saying that's how many little squares of 1 centimeter by 1 centimeter fit inside the triangle. Okay, let's do one more before we, in fact, that's a little bit too easy. Let's do this one. Which of the 4 options here do you think is the correct area of this triangle? So ask yourself, what do you need in order to apply the area rule, and what I feel like I'm just going to go a half times 12 times 9. And then the important bit is I must choose to use the sine of 75. The 42 is just a distraction. And so I'm going to get 52.2 round up to 1 decimal place. And the correct answer would then be A. So what could have gone wrong here? What could have gone wrong is if you use the 42 as the angle. The reason you can't use 42 is you need to use the angle between the 2 sides that you know. And that's why it had to be the 75 and not the 42. And that's probably the most important thing to realize is you can't just use any angle. It must be the angle between 2 known sides for the area rule to work its magic. Okay, cool. I'm very impressed by what you've done so far. And what I want to do to make sure we have a productive second part of the lesson, we need to invest in ourselves. And we invest in ourselves by taking a moment to have a break. So please turn your cameras on and join me in standing up and taking care of your body, because you are a human. And humans need to stand and they need to breathe. And they need to do all sorts of things. Let's start by just swinging our arms. Just feel that nice loose feeling in your arms. Just make sure you don't whack anything. And then maybe shake your arm out a little bit. You want to feel nice and loose. Maybe shake out your legs. Get some blood moving around in your body. Oh, I can feel my body thanking me already. Okay, then what I want to do is I want you to put this arm across like this. And while we're doing this, I want you to stare off into the furthest corner of the room. And the reason we're doing this is to give our eyes a break. You've been staring at a screen and your eyes need a break. So stare off into the furthest corner of the screen and then switch your arms to the opposite arm like this. And then stare off into the furthest corner of the room. And you should feel your eyes relaxing a little bit. Okay, then let's roll our shoulders back. Let's just do 5 rolls back. Let's do 5 rolls forward. And then just shake out your arms again. So shake them out, loosen them up. Okay, let's do some deep breaths. Let's just do 4 deep breaths. So breathe in for about 3 seconds, breathe out for about 3 seconds. So yeah, so hopefully you feel a bit of oxygen coming into your body. And then let's get our heart rates up. We're going to do air skipping, and we're going to do 20 air skips. Pretend you have a virtual skipping rope. Make sure the space around you is clear. And we'll start in 3, 2, 1. Let's go. $15, $16, $17, $18, $19. Do 5 more. 1, 2. And so, okay, so I hope that your eyes had a bit of a break. I hope that you breathe in some fresh oxygen, and that you also felt some blood circulating in your body. Here is today's brain break. See if you can find how much 6 sandwiches plus 3 mealies plus 2 pizzas are equal to. See if the glory can be yours for today. Okay, what do you think? What do you think it's going to be? How much are 2 mealies or 2 corns worth? It does feel like together they have to be 12, which means one of them would have to be 6, I guess. If you think about it, 6 and 6 for each, which over here means that must be 18. And so remember, we're trying to figure out what this is. That's the goal of the brain break. So 1 pizza, if we know our times tables, it's probably going to be like a 6, 7, 8 or something, because it's 12 times something plus that something gives us 91. So like 12 times 5 is 60. So it can't be 12 times 5. Letty says 7. So 12 times 7 is 84. And then plus another 7 is 91. So that's going to be 7. But then watch out, there's 2 pizzas here. So that must be 14. I think. Yes. Yes. Now what? Now remember, there's sandwiches, and I've got to remember BODMAS because I've got multiplying and adding. What do we have for that? I might need my calculator for this, but I'm guessing, like, if you think about taking 14 away, I've got, what am I going to get? People are saying 8. Oh, for 8. So 8, let me try my calculator. So if I go 8 times 18, I get 144 plus 14 gives me 158. You're quite correct. But now that was 8, but there's 4 sandwiches. So each of these is worth 2. And there's more sandwiches here. So I feel like this is 12. So what's my final answer going to be? Kind of, I suppose I'm getting out of times table land here, but I'm going to use my calculator and go 18 times 14 first because of BODMAS, The addition has to get done at the end. What are we going to get for our final answer? Oh, look at this. People are flooding in with the answer. Oh my goodness. Everyone seems to have got it before me. It is 264. Yes. 264. Okay, so really these logic puzzles are just simultaneous equations. They're just written in funky ways, but they're nice to do just to zoom out for a bit and have some fun. And then when you see them on the internet, you feel like, I've got this. Cool. I hope that that was enjoyable. Let us go back to the main purpose of today. So what have we done so far? We did something called the ambiguous case to start tonight's lesson. And then after that, we've been talking about how to find the area rule, or how to find the area of any triangle. And what we found so far is as long as we've got two sides and the included angle, we seem to be golden. So let's apply this to another question. Actually, I tell you what, let's do this one. Find me the correct option to find the area of this triangle. Find me the area of this triangle. So remember that when we use the area rule, we need two sides that are next to each other, but we also need the angle in between those two sides. And so we should be getting something like that. And how does that look if we put it in our calculators? Oh, you can't see my calculator at the moment, but I'm just using it quickly. And you should have got 28.67 or 28.7 if we round off to one decimal place. And that's going to be centimeters squared. Which option is correct? It's going to be B. Look at the chat. I see so many B's that I feel like I need to take it up a notch. So if we read this question, which of the following would correctly work out the area of this triangle? I want you to think about this and then give me which option you think is correct. I'm not going to say anything because I feel like you guys have got this. I'm going to get some water from my kitchen. Okay, what are we getting in the... Oh, I like a little bit of debate. Yes, I see A's and D's and B's and C's. Now, I love it. I love it because it means there's so much learning to be done. So I think which was tricky with this question is they gave you two sides, right? So you've got the 26 and you've got the 14. What you don't have is the thing, and it feels to me like that was the angle I really wanted. Can anybody tell me what is the size of the blue dot angle? How would I do that? Let's go to Letty. I think I saw a hand go up there.
Okay, so what we're gonna do, since it's a triangle, we're gonna say 180 minus 72 minus 24, and the answer is 84.
Perfect. Thank you so much, Letty. So using what Letty suggested there, I think that can help us go in the right direction for the answer. What do we think the answer is for that now? If we were trying to find the area of this triangle, I feel like now I kind of know what I'm dealing with. So I could say, is there one that has 14, 26, and then the sine of 84? And the other thing to realize is it doesn't have to be 14 times 26. It could be 26 times 14. This looks to me like the sine rule. That has no sine in it. And this has no half in it. And so the correct option is D. Okay, so that was harder because you had to find the angle by yourself first. But again, still doable, I think. All right, now things start to get a bit more interesting. Instead of having numbers, we've got letters. And remember, with triangles, the big letters are the vertices or the corners. The little letters are opposite the big ones, and they're on the side. So which of these is the general formula for the area of a triangle? So which of these? Let me know what you think in the chat. Which of these do you think is correct? Ask yourself, when we were doing the area rule, we found two sides and then an angle. Which one do you think fits here? Now, I'm going to throw out these because I know that the area of a triangle must use the sine trig ratio, so it can't be A and C. And if I think about it visually, I want so A and then say B, and now I want the angle in between that, which is C. And so for me, that looks correct. The problem with this one is A and B, and then the angle A is not between. The angle A is down here. And so it doesn't fit the shape of the sine rule. And so the correct option is B. Now, I want to ask that if I know the area is a half A times B times the sine of C, what would complete the formula if I said a half A times C times the sine of what angle? Because you can write the area rule in different ways. What do you think the missing angle would be if I went a half A times C times the sine of what angle? What do you think is going to go in the missing bit there? So I'll get rid of B because I'm not interested. I'm interested in A and C. Now, what's the angle between those two sides? Yes, Toba, I agree. It has to be B. And just to be sneaky, if I wrote a half B times something times the sine of angle A, what would the missing side be in the area rule formula over there? What's in the missing yellow bracket over here? It's just going to be little side. And all I was doing there was I was focusing on the area rule on those two sides and then the angle in between. So the area rule can actually be written, you find the area as long as you have two sides and an angle in between, you're golden. Okay, now, as we get towards the last quarter of the lesson, let's ask ourselves what other types of questions can be asked. What is different about this question? So take a moment and ask yourself, what is different about this question compared to the other question? It doesn't have an angle. Yep. No angle. It would be so nice if we had this angle, but we don't. Well, let's read the question. The area of a triangle is actually given to us. They want to know what is the angle YXZ, or basically this angle down here. So it's a little bit different, but it feels like it's from the same type of question. Who has some ideas about where we might start with this question? Where would you start by trying to do this question? I suppose we could start with the sine rule. Equation, write the info given. Oh, you guys are giving such good suggestions. So let's say 1/2 times 11 times 14. And then what's going to have to come after that? It's going to be the sine, let's call it angle X. So I know all that stuff. What is new is I have this 48. So you have to ask yourself where the 48 goes. And I think the 48 just goes there. Okay, well now I need to get the sine of X by itself. And the way we get it by itself is we just move everything across. So on the bottom, I'm going to have 1/2 times 7 times 14 equals sine X. But now I still haven't got the X yet. What's my final step to get that X? Just the X by itself. What do I need to do? Maybe I should show my calculator to help you here. Let me show my calculator. Can you see the calculator? Yeah. So we go shift sine fraction. Then I had 48.5 times 11 times 14, close bracket, and I get 38.56, which rounded to 1 decimal place should be option A. Yep, that's it. Well done, everyone. Well done. Give me a thumbs up if you followed that. Give me a thumbs down if that was a bit tricky for you. Because it is getting harder now. And I'm going to do one more question, or maybe 2 more, just to keep improving our knowledge. Okay. Let's try and do this one. Fantastic. You guys are doing so well. I'm going to actually just butt out of it for now, and then I'm going to wait for questions. So you give it a go and you ask a question if you're unsure. What do you think the answer to this question is? So you're given the area. So that's a bit like last time, but this is different. They want just one difference is that instead of getting X by itself, what I really want is to get this XY thing by itself. So what if I want to get away on? I need to get the 1/2 and the 8 and the sine of 56. Let's just make sure I've got everything. So there's the half. It came across. The 8 came across. And because they were multiplied on this side, they become divide on this side. So what's my final answer going to be? So we can go, if you want, we can use the fraction button, and then 18 and 0.5 times 8 times the sine of 56, close, equals, and I get 5.42, which if I round off, I'm going to get C, or 5.4. Okay, well, you guys are doing so well. Let's see if we can squeeze in a few more. It's like, it feels like we're on a good run here. See if you can see what matches this one. Which of these options fits the... And think about it carefully, because there's a couple, they all look like sort of correct. So you need to think about what have they given you, what works, what doesn't, etc. So the area is 20. So I think it's either C or D, because I know that the area must be 20. And then this looks fishy to me. There's a plus there. Whereas these ones, they can't work. A half times 12 times 4 times the sine of the angle in between is x. And so my feeling is that C would be the correct answer. And Morang and Ongani and Tebogo and Tati, Fateko all agree. So I think we are on the right track. Let's just check that you've got this idea down and correct. Which of these formulas is correct for the area of a triangle? Let's just make sure you've got this waxed. Yeah, you guys are too good at this now. That wasn't much of a challenge, was it? So the answer is B. So a half A times B times the sine of the angle C, which is the one in between. Okay, last question for today. Last question for today. Find the area of this triangle. Find the area of this triangle. And then once we've done this, we've done tremendously well. Find me the area of this triangle ABC. Use all your knowledge from today to see how you can bring this all together. Maybe somebody can give us a tip in the chat. Where would you start this question? Where's a good place to start? So first of all, I think the whiskers need some sort of Profense, what do you think? I see your hand is up. Can we unmute Profense? Profense, what do you think we need? What's the key thing with this step?
I think it's important to note that the side AB is equal to side AC.
Ah, yes. So those little whisker things mean they're equal. Anything else you noticed?
That angle B is equal to angle C because they're angles opposite equal sides.
Perfect.
Yeah. And then from
Anything
there,
else after that?
that angle A is equals to maybe 80. Yeah, 80.
Perfect. Yes, because you know all triangles add up to 180, so that must be 80. Perfect.
Yep.
Thank you, Rafet. Yeah, that's perfect. So now, with all that help, what is the final answer for the area of the triangle? What is the area of this triangle going to be? Now, just to make sure, we actually should be showing working. So just to make sure, so C was 50, and then we would say the reason, and then we would say A is 80, and that would also have a reason. And the reason would be for this one, angles opposite equal sides. And over here would be sum of angles in triangle. Okay, so half times 7 times the sine of 80. And what do we get for our final answer? Let me bring up the working out here. Yep, the answer is 24.13, and it should be units squared. If it said centimeters, it would be centimeters squared. Okay, you guys have done fantastically well.